In this video, we're going to look at one more example of using integration by parts to evaluate an integral. So our example is to evaluate the integral of square root of 1 minus x squared dx. Okay, using integration by parts, we need to set a u and a dv. So let u equal to the square root of 1 minus x squared, and let dv be the rest, which is just 1 times dx. Let's compute du. Du would be 1/2 times 1 minus x squared to the minus 1/2 times negative 2x times dx. Let's simplify du. We can write it as negative x divided by, after 2's cancel, so negative x divided by square root of 1 minus x squared dx. And the dv gives dv being 1 dx, so we can take v to be x. And now let's use the technique of integration by parts. And we're going to call the integral we are trying to evaluate, that is the integral of square root of 1 minus x squared. We're going to call that u dv integral. The technique says that's equal to u times v. So we have x square root of 1 minus x squared is u times v. And the other integral, which will have normally be a minus, but since du had a minus, this will be plus integral of x squared over square root of 1 minus x squared dx. And that is our v du integral. And so the problem comes down to now in evaluating the v du integral. That is the integral on the right side. And here's how we do that. So we write the integral of x squared over square root of 1 minus x squared dx. Let's add a 0 in the numerator. So x squared plus 0 will not change anything. And the form of 0 we'll take is minus 1 plus 1. Notice that minus 1 plus 1 is 0. We didn't change anything. And now with minus 1 and plus 1 in the numerator, we can separate this into two integrals. The first one will be x squared minus 1 over the square root of 1 minus x squared dx. And then plus 1, the integral of 1 divided by the square root of 1 minus x squared dx. The first integral of the two, we can factor out a minus, so this will be minus the integral of 1 minus x squared in the numerator over square root of 1 minus x squared in the denominator. And the second integral of 1 over the square root of 1 minus x squared, you may recognize that that's the arc sine of x. So for the first integral, we can write the numerator of 1 minus x squared as square root of 1 minus x squared times square root of 1 minus x squared divided by square root of 1 minus x squared dx plus arc sine of x. After canceling square root of 1 minus x squared from numerator and denominator, we have the first integral as negative integral of square root of 1 minus x squared dx plus arc sine of x. And let's put this back into the integral that we are trying to evaluate. So on the left, we have an integral that we want to evaluate of square root of 1 minus x squared. It is equal to x times square root of 1 minus x squared. And then we have plus the integral of x squared over square root of 1 minus x squared, which is negative integral of square root of 1 minus x squared plus arc sine of x. You can see that we can move that integral from the right to the left. They're identical integrals. So on the left, it gives us 2 times the integral of square root of 1 minus x squared dx, which is equal to x square root of 1 minus x squared plus arc sine of x. If we now divide both sides by 2, we have the integral of square root of 1 minus x squared dx as 1/2 x times square root of 1 minus x squared plus 1/2 times arc sine of x. And then we can now add a constant of integration c. And that's the answer.